Hi, chemistry friends. I'm going to make a short little tutorial video to help us with assignment 9.1. The fundamental of stoichiometry is the mole-to-mole conversion, and I want to just make sure we have our lessons solidified before we move on. Let's read first question together from this assignment. It says, given the balanced chemical equation for the production of aluminum oxide, and they give us that equation, and it's worth reading together. I want to read this in terms of the stoichiometry. It says 4 moles of aluminum, the unit 4 stands for moles, reacts with 3 moles of molecular oxygen to form 2 moles of aluminum oxide. The production of aluminum oxide is the product over here, aluminum oxide. Now notice what I've done. I've read this question here where the coefficient stood for the unit moles. 4 moles plus 3 moles combine and rearrange to form 2 moles of product. So now it's going to say, what mole ratio would you use to convert from the given quantity of moles of aluminum to the wanted moles of aluminum oxide? Now remember, a mole ratio, I just want us to think about a unit of conversion where we place what we want to solve for from the given quantity. Think want over given for a mole ratio. When we read the question, it says the given quantity, what mole ratio would you use from the given quantity of moles of aluminum? So the given is moles of aluminum, and remember how we read that from our balanced equation? The moles of aluminum is 4. And it wants us to solve for moles of aluminum oxide. I call that my want. We want the moles of aluminum oxide. And remember what we read there? Its mole was 2. So what does our mole ratio look like for want over given? We want moles of aluminum oxide. It places itself on the top of our conversion factor. We're given moles of aluminum, and therefore the given quantity goes on the bottom. This is the mole ratio we need to report for question 1. Want over given, the coefficient ratio from the balanced equation. That's all we need to do for that first question. 5 points for writing that out. Now the second one, that actually has us solving a problem, and let's read through this as well. It says the Haber process produces ammonia from the elemental forms of nitrogen and hydrogen according to this equation. 1 mole of molecular nitrogen reacts with 3 moles of hydrogen, forming 2 moles of the product who's named ammonia, NH3, a 1:3:2 mole ratio. How many moles of ammonia? That's what we want to solve for. Ammonia, NH3, can be produced from 2.5 moles of hydrogen. That's our given quantity. We want to know moles of ammonia, starting with a number of moles of hydrogen. Show all your work. Well, I want us to always start out by writing the number that's given, the unit that's given, and the label of the reactant we're following. I'm going to write that this is given. Well, that's not how you spell that. Let me fix it. There we go. We have to use our mole ratio. That's our conversion factor for any mole problem. And just like above, we want over given from the balanced equation. And remember, target, what we want is the moles of NH3. So here we have, starting with a given quantity, working to the wanted quantity, we need a conversion factor. And that comes from our balanced equation. We want ammonia. We said its coefficient was a 2. We were provided moles of hydrogen. Its coefficient was a 3. The coefficients from your balanced equation take the mole ratio, and notice what's happened? We cancel moles of hydrogen, and that brings us to moles of NH3. Now, in terms of your calculator, we want to take 2/3 of 2.5. So you're going to simply say 2.5 times 2 divided by 3 equals. And when you hit that, report your answer as moles of ammonia. I'll check your work for you and give you feedback. I hope you found this helpful and get an A+ on this assignment.